Okay, so I'm sorry I did not get to this video earlier, but better late than never. So thank you. Shout out to the 7th grade student that asked for this problem. This is a good one. So it's asking to solve this algebraic inequality, these two, and then also solve it graphically on a number line. So if I build these with algebra tiles, it's a lot easier. I would suggest using the homework tool, which is, let's see, the E tool. I have it pulled up here somewhere. Let's see, right here. This one here. All right. And if you use the E tool, you can build both of those expressions. So we've got -3 plus 3x, and then we have 2 minus 2x's. So we're gonna, what I'm gonna do is, let's see, I need to get this, sorry, moving some things around. I don't have any zero pairs I don't have any zero pairs. Let me pause this for a second. Okay, so I don't have any zero pairs, so there's no like positive x's, or there's no positive 1 tiles to cancel, there's no negative x tiles over here. There's no zero pairs. As a matter of fact, there aren't even any balanced sets. Like I can't remove a positive x and a negative x. Those are not the same on both sides. So I would need to remove something that's the same here, that's the same there. So the first thing I'm going to do is I'm going to add something to this side to get rid of these x's. I only want the x's here. So what I'm going to do is I'm going to add 2 x tiles to make 0 pairs. So those are the 2 x's that I'm going to add. But if I do that, I need to add 2 x's to this side. It must be balanced. So that's what I'm going to do. That's going to get rid of these 2 0 pairs now. And I'm going to want to do the same thing over here, but with the unit tiles. So to get rid of these 3 negative ones, I'm going to add 3 positive ones. So I'm going to add a positive 1 to go with that guy, a positive 1 and a positive 1. And then I'm going to add 3 over here. So 1, 2, 3. Now I can remove my 0 pairs. We can remove my 0 pairs. Whoa. Just these guys here, not the x. So remove those zeros. And now I'm left with 5 x's compared to 5 1's. So if I want to know just what one of those x's is, well, each x has a value of 1. There are 5 x's and there's 5 unit tiles. So if 5 x's is the same thing as 5 1's, that means that 1 x is the same thing as 1 unit. So over here, this simplifies all the way down to 5 x's are less than 5. And if I divided both sides by 5, I would get 5 is less than 1. So if 5 x's are less than 5, that means that 1x is less than 1. Here's my number line. Here's 1. X cannot be 1, so it's an open circle. But it can be anything to the left of that. So it can be 0, it could be -10, it could be -1,000. Any of the things less than 1. For instance, like if I put in 0 here, 0 is smaller than 1, and then solved for this equation, I have 0 3's, which make 0, and -3 is just -3, and then 2 times 0 is 0, and 2 minus 0 is just 2. And yes, in fact, -3 is less than 2. For this guy here, I know that 4/5 of an x is greater or equal to 8. So I want to know what 1 full x is. What is that greater than? What's a full x greater than? So for this one, I did a little number line. You can do a bar model or anything. So this here is going to represent 1 full x. And what I know is that 4/5 of an x, so let's do 4/5 of it. I wish they were a little bit more equal size, but that'll do for right now. So this is 4/5 of an x, and I know that that is 8. 4/5 of an x relates to that 8 there that we see here. this would be 0. So I'm wondering what this is here. What's a full x? And if I count, this is 1, 2, 3, 4 equal parts. So if I divide 8 by 4, I get 2. 2, 4, 6, 8. So a full x must be 10. So 4/5 of an x is greater than 8. Well, 1x, or just x, must be greater than or equal to 10. So if we're doing that on a number line, here's the boundary point at 10. In this case, x can be 10. So x can be 10. So I'm going to fill that in. And I want everything more than 10, which is going to make this true. 10 or more. So like if I use 20 here, so 4/5 of 20 is greater than or equal to 8. I can put that 20 over 1. I can do a little bit of cross-canceling. I can say that 20 is the same thing as 4 times 5. So 5/5, that makes 1. Those make 1. So this is 16 is greater than or equal to 8. That is true. I'm just checking my solutions, just checking to make sure that I have it graphed the right way. All right, thank you very much.